I'm Amitai, and this is Nir, my colleague. And we'll present today a new tool that Intel developed that enables using deep learning easily and fast. Deep learning is an innovative technology in data science today. And this tool enables using it without purchasing any special hardware, without paying any additional money for software. Everything is free of charge and works on your own computer. Before we start, I just want to make a quick survey. How many of you have heard about deep learning before? Please raise your hands. Okay, great, excellent. And how many of you have already used deep learning? Okay, exactly. This is exactly the gap that we are trying to solve to help people who want to use deep learning, who heard about it before, to be able to use it very easily, very quickly. This tool will also be useful for people who already are familiar with deep learning and are already using it, as you will see later on. So I'll start with just a little background. Intel is usually perceived as a hardware company, and of course there are many good reasons for this. But not many people know that in the recent years, data science started to play a major role in Intel. It plays a role both in optimizing the internal processes of the company and in its technology enablement efforts. So for example, in processes like design, manufacturing, sales and marketing, machine learning is widely used. We use it for validating the designs, for saving power in our processors, for telling our sales and marketing people who to call and what to offer them. We have some additional examples. For example, in healthcare, we have a wearables analytics platform that is used for monitoring symptoms of Parkinson's patients and also in monitoring Huntington's patients recently. So Intel does a lot with data science, and as I mentioned, the most innovative method in data science is deep learning, so you've all heard about it. The exciting thing about deep learning is that it is solving real-life cognitive tasks that until a few years ago we all thought that only humans can solve. It is identifying objects in images and localizing them. It is doing natural language processing, answering questions about text. It is recognizing speech, translating into text, translating text between languages, lots of things, and the applications are just increasing. When you do a Google search, you use deep learning. It is used by Facebook, by Amazon, and it's going to be used, of course, in autonomous driving and many other exciting applications. Of course, we won't have time to go into the details of how deep learning works. I'll just remind you that the deep learning model is inspired by how the brain works. So the idea is to have a multi-layer network of neurons. The neurons get some input from the outside world, do some processing, and the outputs of the first layer go as inputs to the next layer, and so on, until at the end we get the output. So the deep learning networks may differ in the number of layers and in the number of neurons, in the connections between them. And this layout of the network is called the network topology. And there are some famous topologies that solve specific problems, and Nir will mention them later on. Two other terms I want to make sure we are familiar with are training and inference. So we usually train the network with a lot of examples. For example, here are images of numbers that we can use as examples, and they are labeled. The network is told, okay, this is 1, this is 2, this is 3, and so on. And then based on the training, the network can infer the answer for a new data, for new data that it receives. For example, it is able to identify that the number 3, the image of 3 is the number 3. What happens in the training is actually that the network learns what should be the strength of connection between the neurons. So for each connection between a pair of neurons, the network learns the weight that makes it learn the training task. So we won't go into more details here, especially since most of you have heard about deep learning before. The issue that we are trying to solve today is that deep learning is not really accessible. So big companies use it, but most data scientists don't use it yet. And there are several reasons for that. So one reason is that the open source for deep learning is quite difficult to install. A bigger reason is that the open source for deep learning doesn't run fast. So you need lots of computers or buying special hardware to be able to run it. And the third reason is that it takes some expertise to be able to use it and tune it for your needs. And today we're trying to solve all these issues, bring deep learning for all, make it accessible to developers and data scientists alike. And we're going to present the Intel Deep Learning SDK, which enables easy and fast development of deployment of deep learning solutions. So I would like to invite my colleague Nir, who led the team who developed the SDK, to present the product and show you a demo as well. Yeah.
Thank you very much, Amitai. So as Amitai mentioned, we developed the Deep Learning SDK as a tool, a set of tools for you guys to be able to easily develop deep learning neural networks and also deploy them. So basically, it's a tool that provides an end-to-end experience. From the moment you decide you want to start practicing deep learning, you don't have to have too much knowledge, just a basic understanding of the concept. And you can use your existing hardware, so you don't need to purchase additional hardware. Of course, you can if you want, and you get better performance. But even with your existing hardware, we will provide significantly better performance, and also existing in popular frameworks. So it's not a new framework that you need to learn. Once you get to know this tool, you can work with the existing popular frameworks. So when we developed the tool, we basically had 3 principles in mind. That we took these principles with us throughout the development. The first is we want to make it really, really easy to start. Just like you plug and play your TV and it works, we want to make an easy start for deep learning, so it's a very simple installation process, and also a very simple and smooth process of the development and deployment of the deep learning models. The second principle is maximize the performance. So again, today, if you download, so if I talk about the ease of use, if you download a deep learning framework from the internet, it's not that easy, and also you get a decent performance, but not the best that you can. We took and optimized the deep learning frameworks, the popular frameworks, to work best on Intel hardware. And you get, by using this tool, both for training and inference, a superior performance on top of the open source. So for example, for the example that we will show today for Café, it's roughly about 10 times faster than using the open source framework on top of your existing hardware. And the third principle that we took in mind is we want to increase productivity. So we want to create some productivity tools, like machine learning has a lot of mature productivity tools. For deep learning, this is relatively new. So tools that will enable you to do a faster time from the moment you start to work on your model until the time you train it and also deploy it. And also some tools that will increase the accuracy of your models. So we had these 3 principles in mind, and I hope you will see them in the demo. I want to demo the tool, but also show you a real use case that we did at Intel, exercising deep learning. And I don't know if any of you know, but last month in August, our CEO announced a new product by Intel, an augmented reality helmet. So you put this helmet on, you see the environment, and you communicate with the helmet using speech and hand recognition. So we want to show you today the process of doing training of hand recognition. Basically, this is what the helmet will see. It needs to identify what is a hand, and here a hand is colored in green, and other objects that here in the image are colored in purple. So basically, the idea is that you need to do, there are several deep learning tasks here, like object detection, segmentation, but we will do the classification of the objects once they were identified. And we will show you the end-to-end process, all within a very short time, of creating a deep learning model for identifying hands using deep learning. So the data set that we're going to use, first, if you can understand that the use case is showing image classification, and we're going to use a data set of hands. So pictures of hands. At the top part, you see pictures of hands, very different postures. And the bottom part, you see pictures of non-hands pictures, which could be confusing. And we'll see the process of the computer learning, but just by us giving, some samples of hands, some samples of non-hands, and the computer can learn and identify these hands. So without further ado, let's skip to the demo. Not skip, go to the demo. And I want to show you first, the first part is the installation part. And as we said, usually installation of deep learning frameworks, it means you need to connect to some GitHub. After you chose the framework, you need to download the source code, you need to compile it. Maybe you want a better performance, so you, depending on your hardware, you will take a primitive library, add it to your compilation. Anyway, it requires a lot of expertise. What we are offering here is we're saying, okay, you can still use your server, so you get the better performance of using a server, not a laptop. Although actually the demo itself, I'm going to run deep learning on this Mac. But you can still do this on a server. To make it easier for you, we're creating a GUI for installing. So it's like any application you install on your Windows machine or on your Mac. You download an installer. You provide some minimal set of details, like here is a password to protect your data. This data is going to be accessible for you from the server on a web browser, so you need a password to protect your data privacy. You need to provide the IP address or the name of the server, and just the username and password that give you access, will give us access to install on the server. And then all you need to do is you click next, and the installation happens for you. Okay, so this is, you're going to see a live demo, hopefully it will work, of downloading and installing the entire framework. An upgrade process is obviously faster. The first installation will take a little bit longer, so a couple of minutes. But basically, this is all you need to do. You need a clean server with any Linux environment, and this will do this for you from your laptop. So you don't need to connect to it. You don't need to know any scripts, anything. Once you install the environment, you get a link to open Web UI. And again, the process that we're going to show is classification of images of hands. So first, we need to upload the set of images. So this is a unique feature that we have here in order for you not to need even to connect to the server to get the data. All you need to do is you choose your own data set. It can be hands, it can be numbers, it can be faces of your friends. You put them categorized under folders. You create a folder of the data with subfolders of the different categories. And you compress all of this to an archive file, and you upload the file through this user interface. Okay, I'll save this process right now, but you browse your computer, you upload the archive file, you see the progress of the upload and the uncompression, and then eventually in the history you can see the different data sets that we uploaded here. Next, after we uploaded the files, we need to create a data set. So deep learning doesn't work on files necessarily, but on databases. The framework that we're using here, if you know any different frameworks, is Caffe. So we're going to create a Caffe-supported data set. And again, in order to make it very easy, you can see these are the data sets that I created before. In order to make it very easy, we actually created a wizard. So you don't need to understand too much. We will take you step by step, hand in hand, in order to create this data set. Just give it a name. You put the source file of where all the files that we just uploaded. And then you have some flexibility with what you can do. You can save some of the file, the data in the data set for validation and testing. So you run through the model, and then you have some of the data saved aside to do the validation. A really nice feature that we have here is we had some use cases where you don't have the same amount of data for each of the categories. So this is a common problem with data science. Not always you have an equal sample of each category. So we have here a nice feature of augmenting your data. And there are different types of augmentation. Not all of them apply to all kinds of data sets, but this is all flexible. You can use it. Of course, you can skip that and just click next to the next step. So this is selecting the data folder and the data properties. The next step would be, again, these are images. Sometimes they don't come in the same size. Sometimes some of them are in color, some of them are in grayscale. Usually what a data scientist will need to do is to write some kind of a script to normalize all the data. Here again, we're trying to make it easier for you. You can choose if it's color or grayscale. You can resize the image. You can choose one of any resize methods very easily. And again, you can just leave it as is and click next. Last step of the dataset creation is to select the database backend, and then with a click of a button, you create your dataset. Once the dataset is created, you can browse through the data. So here I have an example of data that is unbalanced. So you can very easily see here, okay, that I have a problem, and then you can go back and create the data augmentation. Here is an example of the data that is balanced. So this is the hands data, pictures of hands and pictures of objects that are not hands. And I'll just give you another example of numbers so you have more variety of data. So this is a nice way to browse through the data, understand what it is. Just before we go into creating the deep learning model and actually telling the computer to learn the process of hands identification. So again, for deep learning, for the model, we created a wizard. Okay, the idea, again, making it very easy, step hand in hand. We'll do the hands demo. You can give it a name, give it a description, so it's easier to find. And then you need to select the data set. You might want to repeat the same process with different data sets. You will get different results. So we'll select the hands data set. And next, I want to select the topology. As Amitai said, there are some existing topologies to choose from. These are deep learning neural networks that has proven to be very efficient. You will be able to also create your own topology here. And also a nice feature that we have here is fine-tuning. So we are pre-training some models for you. And this is a process, again, we didn't invent this. We're just making it easier for you to do. You can select one of two fine-tuning options. This will make the process for you first faster, and second, you should get better results because you're getting a model that was already pre-trained with a large set of images. Some additional data transformations are available. Again, this may be useful in the training process if you got. This is an iterative process, so sometimes you don't get the results you want. You want to do some modifications. And I think the most important part here is some of these parameters that are affecting the model. So we are providing optimized parameters based on your hardware and based on the topology that you already selected in the data set. But this is still something that you may want to use the flexibility of changing the solver type, changing some of the batch size, sometimes influence the accuracy. Again, if you are just starting and want to play with it, just use the defaults. If you want to get improved accuracy, you want more flexibility, you can do that. And then clicking run, I will start the training process. Now another strong thing about this tool is that it will show you the progress. So first, training a deep learning neural network is a process that takes time. So we can save you some of the time. First, you will know exactly how much time it will take. So we give you the estimated time. But you can also see the process of the training. So you will see the accuracy going up. You will see the train loss, which is the diff between the validation data sets and the images going down. You have some really nice tool to show you the progress. And you can see, for example, if you're getting it to an overfitting status, and then you can stop the model and retrain it. And some additional information that we have here, I'll take this is a model that has completed the training. We can browse through the data set. So if you remember the images, here the computer will, this is the validation data set, so we can see the identification, hands, not hands. Okay? And if something was not correctly identified, then let's choose this data set. We can easily see that, okay? And you can see the prediction probability. We can test single images. Okay, so I can select an image and hope the computer will identify it correctly. So this is a hand. Let's try another one. Okay, also a hand, not 100% probability. So you can test your model. You can get some more analysis. Let's see this one, for example. So here is a confusion matrix. This is for all the different inputs and the outputs. You can see that this is the numbers. So number 0 was identified 589 times correctly, but 2 times it was not identified correctly. So it's really outstanding if you have some issues with the model. And obviously you can go and you can download the model, okay, and use it. Click download and use it with any deployment tool on any platform that you want to use. In the future, we will provide an end-to-end experience. So you have another tab here where you select what is your edge device, where do you want to inference. You want to inference on the data center, then you use the better accuracy of the model. If you want to use some edge device like a mobile phone or a Google Glass, you may need to compress the model. You might want to compromise on accuracy, maybe not. So we will provide all these compression models and deployment. So basically that's the end-to-end process. And you see, I think it took me like 10 minutes to do it from scratch. End-to-end process of training deep learning neural networks. So we at Intel, what we want to do and we are committed to do is basically we want to bring deep learning to everyone, as Amitai said, and we want to democratize deep learning. Okay, and we're committed to that. So what you've seen today is just the first preview of a tool, which, by the way, you are invited to register and be one of our first early adopters. But we have a lot of things already going on in the development of the tool. So first, the demo that you have seen is working on existing hardware and also is supporting a CAFE framework. There are a lot of other deep learning frameworks. We are going to implement these deep learning frameworks in this tool, starting with TensorFlow, for example, and support additional hardware platforms. So Intel has a rich roadmap of platforms that can accelerate even further the deep learning process. So if the process is not fast enough for you, you can still use the tool and use better hardware. We also have the end-to-end user experience of plug and deploy, not just plug and train. So get in one tool, you can start from training and deploy the tool. Second, we want to continue and provide improved performance. So you will be able to run this both on a single machine, for example, which has the highest, the lowest cost and highest value sometimes. But if you need the performance, you can run it on a cluster of machines and get significantly more performance and faster time to model. Second, I just showed you this can work on-premise. So on your server, if you have some sensitive data, you can use it in your company or your personal server or something. And the second option would be to run it on cloud. Maybe you want the better performance. You don't want to purchase any hardware. So you can use it on Amazon Cloud, for example. And of course, we are continuing to optimize the deep learning frameworks. So continue to provide additional optimizations in that area and optimize the hardware primitives. So software optimizations that will bring you better performance. And again, in the third pillar of increased productivity, we have a long list of features that will help you get better accuracy. Okay, for example, running several models in parallel and choosing for you the best model. Doing the parameters optimizations that I showed you before, tweaking them for you to get better accuracy automatically. Some additional visualization tools like the confusion matrix that you saw and the graphs. So we are working on additional tools like this. We want to introduce additional use cases. So the example that we showed was on text. On images, we want to deploy this, develop this also for text, natural language processing, and for speech. And also the plan is this is a free tool, as Amitai said, but we want this to be an open source so the community can contribute. And this will help increase productivity for everyone. So as I said, this is now going to be on a technical preview. This is going to be by the end of the year publicly released, but in a few weeks you can already download and try to use the tool. Use the tool for your own use cases. All you need to do is go into the link and register. And you can come see the tool and play with it in our booth here at the conference. And I think this would be a great time for questions. Yes, please.
When I use the SDK, is it sending my data off-premise, or is my data that I'm modeling staying completely stable?
So when you use this first version is for on-premise, and it's going to be only on your premise. We're not collecting any data on your data. So it's going to stay on your servers, not exposed outside. That's why we have the security in place as well. So you definitely can run it from command line. You can benefit from installing the SDK, getting the better performance. And if you want the full richness of the framework and you want to run it from command line, then definitely you can connect to the framework itself and run it from there. The features of the models themselves. This is one of the features that I said that we're working on. So you will be able to see each layer what it contributes for the accuracy, and then you can tweak it and then maybe get the same accuracy with the faster model. But at this point, it's not available yet. So we plan to release every 3 months a version of it. This technical preview is the first release, so I believe around the end of the year or the beginning of next year we'll have another version. Every 3 months we want to release a new version with a new use case. Thanks.
Once you've generated a model, how does scoring work? Do you export UML and store someplace else, or do you store using the SDK?
So you can do scoring in the SDK for testing. Part of the SDK will be, and again, by the end of the year, we'll have a beta also for the deployment part. So there will be an end-to-end experience where you can select your target hardware, where you want to do the inferencing and the testing, and you will be able to deploy it using the same tool. At this point, you'll have to download the model and deploy it to the hardware you want to run. You can do it in the data center. You can do it on the edge.
But when you download the model, what form is it in?
So this one is a cafe model.
Oh, okay.
Yeah. Any other questions?
Other questions?
Thank you very much.
Thank you for listening.